Hello, everyone, and welcome back. Today, we will dive deep into how functions work in Solidity, how to declare them, call them, and utilize function modifiers to control their behavior. Whether you are a beginner or looking to sharpen your Solidity skills, this video will provide you with the insights you need. Let's start with the basic. Function in Solidity is a reusable block of code designed to perform a specific task within a smart contract. Functions help in managing and reducing code redundancy and memory usage, which is important for efficient smart contract development. To declare a function in Solidity, you use a function as a keyword followed by a unique name. This name should be descriptive of the function's purpose and not conflict with reserved keyword. After that, we have a parameter list, and then we have a scope returns and return type. And we will explain all of these, inshallah. Let's take this example. Here we have this contract, and we define a function to calculate a sum of two numbers. So we have a function, and then we have a function name, which is add. And here, as you can see, there is no parameter list. After that, we have a scope return, which is public, and return type, which is unit here. The function here is declared as a pure. That means it's indicating that it doesn't modify the contract state. What about the calling functions? Once you've declared a function, you can call it from other parts of your contract or even from other contracts. Simply use the function name followed by the parentheses, passing any required arguments within the parentheses. Let's take this example. As you can see here, we have two functions. We have a square root and we have add function. The first one, which is square root, to calculate the square root of the num. And in this function, which is add, we call the square root to calculate the square root for the sum, which is the summation of number one and number two. And as you can see here, we have this result. Now, let's talk about the return statement, which is used to send back a value from the function to its caller. In Solidity, you can return a single value or multiple values as long as the data types match the declared return type. Let's take this example. We have function called here. We have this function called return example, and it doesn't pass any parameter, but it returns 3 unit variables and 1 string. So here we have number one, number two, and we have a summation of number one and number two. We have a product of number one and number two, and we have a difference between number two and number one. And after that, we have a message that saved in or assigned to the memory variable. So this data or this function return example will return with the sum value, product value, difference value, and the message. So it returns multiple values, as you can see here in the output. We have 26, 160, and 6. And the last one is multiple return values. In Solidity, we have something called function modifiers. What does it mean? Modifiers add a layer of control to your function. They allow you to automatically check conditions before or after function executes. This is useful for tasks like access control, input validation, or state modification checks. How we can create and use modifier? Creating modifier involves defining it with the modifier keyword, followed by the unique name and a block of code that defines its behavior. This syntax defines the basic modifier. Modifiers can also take parameters to make them more dynamic. Now, before going deep into modifiers, let's illustrate an essential component of Solidity modifiers known as merge wildcard. What does it mean? This feature plays an important role in defining the execution flow of the function with its associated modifier. In Solidity, the merge wildcard is represented by underscore, as you can see here. It indicates the point at which function's own code should executing during the modifier's execution. Here, we have a modifier is admin. The require statement here. Check first if the message sender is admin of the contract or not. If the condition is true, the message or the merge wildcard, which is here underscore, allow the execution to continue the function it modifies. So you will not be able to continue to the function if the message sender here is not the admin. This is what we mean by merge wildcard. Actually, modifier can be designed with or without argument. As you can see here, creating a modifier without argument is straightforward. You can define it with or without parentheses. Both declarations are valid and function the same way. Let's examine a practical example to see how modifier without argument is used in smart contract. As you can see here, in this contract, here, in this contract, we have a modifier called isAdmin. The isAdmin modifier check if the caller is the admin before allowing a change to employee details. So before going here to this function and go to employee details function, we should check if the caller is the admin or not. If it uses how we can do that, it uses the require statement to enforce this rule and doesn't need any external argument. So we have required here. If the message sender here is admin, it will allow to go to the other function. Notice how the admin address is set in the constructor and used in the isAdmin modifier. It means what? It means here, the admin, which is a message sender, actually define in constructor here, then passed to the modifier. So this pattern ensures that only account that deploy the contract can call functions protected by the isAdmin modifier. Here, require admin equal to message.sender. This step is essential for maintaining the secure access control in decentralized applications. Finally, this function, which is enter details function, use the isAdmin modifier to restrict access. As you can see here, we have the function here, and this is the parameters of the function, and we applied isAdmin modifier to this function. It means just if the admin, just the admin will access these functions and modify or edit the employee information. What about the modifier with argument? A function modifier with argument can take parameters that influence its behavior. This makes the modifier reusable and adaptable to various scenarios within your contract. First, let's look at the syntax for creating a modifier that accepts arguments. Here, we have a modifier. Then we have a modifier name, which is the name of your modifier, and the argument here name as a parameters, which can use to conditionally execute code within the modifier. Now let's apply this concept with a practical example. Here we will create, as you can see here, we will create modifier that check if the individual has a certain level of experience before allowing them to perform an action. So in this contract, is experienced here is a modifier. Takes an integer, experience here, as an argument. Then check this experience. If it is greater or equal to 5, then okay. Else, revert a message which must have a minimum of 5 years of experience to have the access to the function. So to use this modifier, we simply include our function definition, passing, as you can see here, we have the function. This is the entire details of the name of the function. This is the argument of the, or parameter, sorry, of the function. And after that, we applied this modifier, x is experience 7. It means what? It means the employee with the experience more than with the experience 7 can access these functions and modify the employee details. As you can see here, after check the experience, they allow them to enter their details or the employee details. This effectively enforces our experience requirement dynamically. Okay, what about implementing multiple modifiers in Solidity function? Is it possible? In Solidity, we can attach more than one modifier to function. Each modifier can check a different condition or perform various actions before allowing the function to execute. Consider a scenario where a function must be accessible only by the admin and the caller must have certain level of experience. So we define two modifiers, is admin and is experienced. Is admin to check if the caller is the admin, while is experience check for at least 5 years of experience. So this is the syntax of assign multiple modifier to function, which we will discover in the following example. Now let's apply these modifiers to a function. Here we have this function, which is entire details. This is the parameters. And here we applied two modifiers, which is admin and is experienced. The is experienced with is admin is a modifier without argument. Is experienced is a modifier with argument, which is the number of experience, which is 7 here. So the function will only execute if the caller is the admin and has at least 7 years of experience. The modifier ensures both conditions are met before the function process any logic. So you've now seen how effectively using multiple modifiers in Solidity to create secure and conditionally controlled functions. This capability enhances the security and functionality of your smart contracts. So thank you for joining us and stay tuned for more exciting Solidity tutorials.